Hello, everybody. I did not know my mouth is muted. Hello. So sorry, I didn't know my mic is muted. So we are going to continue our React class by treating React performance optimization. So we are starting by taking what is React and React performance optimization. And in this class, we are going to be talking about a lot of techniques on how to make our React application fast and efficient. So basically, building a fast and reliable system, we need to put in place all the methods, all the metrics, and things that can make our application be fast. It doesn't even matter alone that the system is solving a problem. The system needs to be reliable, and being reliable means that it needs to be fast. So now, why performance matters in React application? So performance matters in React application because the user experience performance directly affects user engagement and retention. So what this basically means that the performance of the app, it needs to be fast, super fast, because the way user interacts with the system, whenever you find yourself on a website, let's assume an e-commerce system like Amazon or Jumia. That kind of system is a very large system that the user engagement is very high. It's on a high end, and it loads a lot of data from the back end on the server. Now, let us now imagine the moment we are scrolling on the app, we are trying to fetch or look for a specific product of our choice. The system is very slow. It's very slow. Loading the image is not loading. The data is not reflecting. The system is super slow. So now, the engagement on that website will drop drastically, and the retention rate means that you have a specific user. Let us assume we have 10 or 10,000 users using our system. Retention rate, they have to be on the system using it actively without dropping. So it's not only the UI, how beautiful the website is, but how fast it is, how easy it is to be in, how easy it to use for user. It needs to be easily accessible for them. Slow application can cause user frustration. This is very, very, very key, because all of us can relate to these things. We might have experience with websites that are very slow. It keep loading before it can load a single website. So now, what are the things that cause all these things, and the ways we can solve this problem? The problems might be from the server or the backend, but sometimes as a front-end engineer, we need to put these things in mind as we are building our application or trying to ship it to production. So now, we're going to talk about the techniques we can use to optimize all these things. Now, for efficiency, optimize application are more efficient and consume fewer resources. Now, the fact about using a fewer resources, it's very important, because example of a resources that is being used whenever the website is loading is something we all know: memory. When you load the website that is very fast, or the load on the data is very low, the website will be fast. That means that the memory that it will consume will be low. It can load like a 2 kilobytes, consume a 2 kilobytes, compare to a system or a website or a web page that takes time to load, to pull like maybe 10 or 15 MB, and it's going to eat up our memory. So fewer resources. You can bundle a whole lot of application under 10 kilobytes and it will be very fast. And also the scalability of that website will be very easy, or the web page or the web system will be very easy. Can you guys hear me? Hello, good evening. Can everybody hear me? All right. So now, common causes of poor React performance. I believe we all understand what it is that we are trying to solve. We are trying to understand how to make a system very fast. Now, what are the things that cause all these things? Sometimes the issue is not on the back end. The issue is might fall to the front end we are building. That is that sometimes you might re-rendering a single component. Let's assume, for example, the e-commerce system I cite as an example the other time. The component keeps rendering. It keep calling the API. Now, the website will keep on loading. Unnecessary renders. React component rendering more than necessary can degrade performance. I believe we've worked with React components in our last class and also a class before. You guys are familiar with React and React navigation and all. So now you are now working with components trying to load a dashboard, and when you load the dashboard, or maybe your hooks is trying to consume and is on mounting every time, or your use effect, you didn't handle your hooks very well. It keeps making API requests to load the web page. So now that kind of performance, that kind of issue is not on the server. The issue is from the front end. And these are the things to put in mind whenever you want to debug that kind of a problem. Pick it from a easy one. Okay, let me check the components. Is the component rendering? No, the component is not the rendering. All right, let me check the API. Is it getting the adequate data? Okay, now the API is getting the adequate data. How are you getting the data? We have something whenever you guys start working with API, you guys start making API requests. One of the techniques for writing a user-friendly API request API is that the API needs to implement some techniques like sorting, limits, and orders. Now, let me explain what that means. When we start working on our Node.js and our backend, these things you guys can write it down. We are going to implement all these things when we start the backend. Imagine on the web page, the e-commerce web page, like I cite the example the other time, you want to load the web page, all the data, the products. We have 1,000 products in the database. Are we supposed to load 1,000 records and populate on the web page on a single API? That is a bad design. Number one, the API will take time before it give out the data. The latency will be very high. Two, the components, the web on our React, we keep loading, waiting to get the data from the API. So that's a very bad design, both on the back end and on the front end. Now, the API to solve this on the back end, you should implement a limit that when you want to make the API to get the product, give me 20 out of the 1,000. Now, the issue is not on the front end, on the back end. It's giving you 20 data. You can handle 20 data on the front end very well. It will not consume the memory that is the resources. It's going to use a little resource. That's how to solve all those problems over there. Now, the large bundle. What do we mean by this? The larger the bundle, the longer it takes to load and initialize the app. This is very easy for us. Now, let me explain what this means for us. Let me show you guys my code. I believe you guys have React code incoming. You guys already have React application initialized on the system. Can you guys hear me? All right. Let me share my. Now, this is the React app. What we are running here is a development mode. This app, when we check the size, is going to be much. So now when you bundle this app, this folder as it is like this, you bundle it, the size will be large. But when you bundle a compiled file of the app, that is, you want to run it in the production environment, it will give us a limited file. So that's what we mean by that over here. What we bundle. Can you guys see my screen? All right. How about now? Can you guys see my screen? Maybe it's my network. Let's give it a minute. You guys cannot see my screen. How about now? All right, I think it's up now. All right, so now this is what I mean on the code. When you run this app, what we mean by the bundle, this folder itself, if we check the file size for this folder, let me check the size itself. Okay, this is the file, the size 363 MB. That is very large. It's way too much, because this app is a very simple app. Just how many components do we have here? Just one component. And if we run it in development mode, it will be fast. But that does not mean that when we deploy it, it's going to be faster. It will be very slow in production. So to now bundle the app, we can use the React production environment build for it to build the app, which is npm run build. Now, you guys should see. All right. When you want to build the app for production, you want to bundle it, all you need to do is just type npm run build. So now, this will bundle the app. It will optimize it, compile everything into chunks. I don't know if you guys can see my screen. I'm showing code. I want you guys to pay attention to what we have on the terminal. All right. Okay. So can you guys see this? So creating an optimized production build. So it will compile the app. It will build it. npm run build. You can do that. So now, the app is compiled into chunks. Now, can we all see the sizes of the app now? What it compiled to? 46.56 kilobytes, 1.78 kilobytes, and 342 kilobytes. Everything will be in kilobytes. So now this is the file, the folder, the build. Now, if we check this build, we check the size of this build folder. Can we all see the size now? 556 kilobytes. Compared to the actual size, that 356. Can we see the difference? That is way too much to deploy. We should pay attention to that. It is very, very high. the file size is too much. Okay, I'm going to show us how to detect the production environment and the development environment soon. All right, so now we also have something called the blocking JavaScript execution. What does this mean? Long running operation that blocks the main thread, affect the UI's responsiveness. This is very, very important. For example, let me give us an example now. Let's assume you are trying to perform an operation that requires you to keep on, like maybe you made a typo error and you are looping through a data and you enter an infinite loop in your data. I don't know if any of us have come across this type of issue before. Infinite loop, your condition get out of range, you keep looping the data, the components will not load. The components will just keep loading, and you can check your console. The moment you are doing all these things, it's eating up the memory and the website is not loading. Your UI, the components will not load. All right, so we also have something called inefficient updates to the DOM. Excessive or unnecessary updates to the DOM slow down the application. What do we mean by this? What we mean by this is that we understand that we update the DOM, the document object model, with JavaScript. We modify our HTML. So now we keep updating the DOM every time. That will slow down the application. I mean, the user, for the user itself, it will slow down. Let me give us an example. Let's assume the moment you implement something called mouse over, and the moment you drag mouse over a specific text, you want the text to zoom out and zoom in, zoom out, zoom in, zoom out, zoom in. Now, that kind of operation, let's assume you define a function that accepts the current text the mouse is on. I want us to pay attention to what I'm saying over here. You define a function that accepts the current text the mouse is on. Now, you are selecting the DOM at the moment. You now want to add an effect to the specific text. You are updating the DOM. Like, okay, when the mouse is on courses, select the courses, add bold to the style, font size of 14, and pop up in a split seconds. You are updating the text, the DOM. Now that will happen, and the moment I mouse out, you want it to reset to the default settings. That will work perfectly. But every time you now move your mouse over every text, that thing is happening. Unnecessary and excessive DOM updates. The system, we keep calling that function pum pum pum. We call it mouse in, mouse out, mouse over, mouse out, mouse over, mouse out, and all those operations, it will kill each other. I don't know if you. I don't know. I don't want to let us to go more into details of how this operation works, because every execution on the web page and JavaScript, it will kill each of it. I want us to go add it up on what we call queue, because it is a data structures to store data, and every operation is being queued and it will definitely execute. So that's what we mean by excessive and unnecessary DOM updates. I really want us to, I believe everyone should understand that we can talk more about it. All right. Also, we have something we called okay, now the next one is React performance. Okay, that's topic. Use callback hook. This is very, very important. And whenever we start working with functional components, you guys will be very, very familiar with hook, because React has a lot of hook to perform a lot of things. Now, let me give a like the example we made the other time. This use callback is a specific hook that happens. Okay, when to use callback hook when passing callback down to child component that relies on the referential equality. What does this mean? This use callback, you use it whenever you want things to happen. For example, you define a state, you store it in a use state hook, and you perform a function, you define a function to make an API request. You now pass it into this use callback. This dependency over here, this dependency you guys see over here, it's an array that accepts a generic data. It can be it can be a variable you define it as in the use state, but you want this to execute every time or whenever the dependency change. I believe, I want to believe you guys understand what we mean by the hook, and how hooks work in React. So now this hook need to come in place to undo everything in the components. This specific function don't execute unless this thing happen. This dependency will be the condition to undo that. Until this dependency change, do this. That's when this thing will happen. All right. So now we now have something we called memoization. This is very, like this memoization right here is a very, very interesting part of React optimization, because the engineering that powers this memoization, because on the front end you can call it memoization, but in the real sense of engineering is called caching. Hello, can everybody hear me? I want to understand you guys can hear me, because this part is one of the interesting parts. Hello, can you guys hear me? All right. So like I said, memoization is just a term used in the front end system to refer to what we know as caching in engineering. Now, what is caching? Let me explain that. What we mean by caching is one of the process to optimize the system, to make it scale and reliable. That is, you want to catch a specific data so that the next time you want to use that data, instead of you to perform the operation that results to that thing, all you need to do is just pick the data from the cache without actually performing the operation again. Let me give us like a real life example for that. When you log in into a specific application, the moment you log in, you get your data. When you want to access an application, maybe when you access your Instagram, or you access your school portal or anything, or maybe a social media app, when you log in, you get your data. Now, when you go to your profile, the components that display your profile to you, such as your picture, your name, your information, that component will load. It will load. It will keep loading to fetch your data from the server. Now, the data is successfully fetched and display and render on the components. Now, You now go back from that component. Maybe you visit reuse, you visit search, you watch somebody else's account and everything. You now go back to your profile. Now, let's now assume you have low internet connection that time. The components need to make an API request to fetch your profile data and render it again. 2 times the same steps when you render your profile inside the same application. That is not scalable. What we need to do is to catch the data the first time the data and the component fetch the data. So now the second time you now go back to that component, your data will still be displayed over there. So that's simple terms for catching and a real life use case for catching. But we have a lot of use case for catching. But now, in terms of front end, React, to be precise, how do we use it? This is a simple definition of how we use React Memo in the front end. What it does is that when a component render in the first time, the data that you put in that component will be catch. But now it will only re-render only if the data in the component change. Do you guys understand that? Hello, are you guys there? I don't know if you guys can hear me or my screen is freeze. Is there any issue? All right. Before we proceed, do I need to recap on anything? Maybe you guys have something that you guys did not understand, because I believe I've been speaking a lot without actually implementing the code. But based on today's class, this is what it is. Everything is not always about the code. I want us to understand all these techniques and everything, because you can be asked anytime, what do you understand by this? What do you understand by this? All right, let me recap a bit. Let's not forget, the purpose of today's class is to understand how to optimize our application. And when we are talking about optimization, what do we mean? We want the system to be reliable. Now, what are the things to put in place when we want our system to be reliable? What are the key factors to determine that? How fast is the system is? The system is faster. It does not require too much latency to load. What do we mean by latency? That is the response time for the app to load. You find yourself in a specific location that your network is not strong. It only brings maybe is on 2 kilobytes or 3 kilobytes per seconds, MB per seconds. Your data, your internet is not that strong, but the system can still perform very well when the data is not strong, because it's very light. The system, the website is the application is very light. It's a lightweight system. It does not require like 5 MB to load the web page, or the website will keep loading until you give the component, display the components. I believe every one of us might one time experience this type of issue, unable to access a specific website. Maybe they now tell you change your data, change your internet. What network are you using? Oh, I'm using this network. The website is loading over here. All these things, all these websites, sometimes the issue is not the network provider. The issue is actually coming from the system itself because it's not light, it's not fast. And to now do that, what are the things to do? There are a lot of mechanisms we can use to optimize how the component is being rendered. The component is not reloading every time we load it. We are not running on a large system. The memory that requires for the website, for the application to load, is very small because the app itself, the data the app you're returning is very light. Unnecessary DOM updates. We are not performing a lot of um animation, a lot of react display on the DOM that can eat up or slow down the system. One of the things, the hook we can use to undo these things is use callback hook that allow the components to load and reload only when the dependency passed to it is changed. And some of the use case that we can use to do that, as an example, is the caching. We can leverage React use memo or react.memo to handle these things. When you use React memo to wrap these expensive components, these expensive components, the moment the application loads it, it will catch this data in memory. So if the data in the component did not change, it will not invalidate the cache. It will not need it will not need to make an API request to update the components. For example, let me give us an example. All of us we use Instagram. When you off your data on your Instagram, you can still have access to some data. You can still be scrolling, playing video, checking pictures, swipe right, swipe left. Why? Because the moment you load that app, it catch those things in the memory. You already save it. So that's catching. That's another use case of catching. Now, to achieve that, we use React memo to catch the components. So when you don't have access to internet or the components did not change, maybe the data did not change, it will not render. Let me cite an example of the profile component I cited the other time. When you log into your app, on your profile page and profile components that display your name and your image, your name is still there, it did not change. But the moment you update your profile name, the components will need to reload and catch again because the data in the components has already been changed. That's when the components will reload, but it will catch it. All right, let us proceed. So another method that is a general method that we mostly use is called lazy loading. Let me use that word because that's the general word used for that, because you can hear developers saying that, oh, a component is not loading this. Okay, why not lazy load the system? What does lazy load means? Lazy load in React means that, okay, let me explain the code splitting first. Code splitting means that breaking up large JavaScript bundle to smaller chunks that are loaded on demand rather than loading everything up front. Can we all understand that? Breaking up JavaScript application, like you break it up into smaller chunks and load everything. Load rather than loading everything up front, you load it small by one. Let me give us an example. When you load a web page, on the header, let us zoom on the header, you are going to have a navigation bar: home, about, services, contacts. Do we understand that the moment that web page load, some application will load all the web page for us? It will load it into the memory, but the system will be slow. That's a bad design and a bad practice. What we should have implemented is that you only load the page the user wants. For example, when you go to the dashboard or the home page on the landing page, load that landing page for them alone, solely that alone. When they click on services, load the services without loading the rest of the components. And now, the moment you load the services, you load the home page, catch it, so that when they come back from home page to services, you don't make API request or you don't re-render the components every time. So that's what we call by lazy loading. You lazy load the components. Are we all there? Can you guys hear me? Hello? All right. So now, what is now the process for using lazy loading, for loading to implement a lazy load on a component? Now, you wrap the component when you want to use it. Let's assume this page is where you are loading the navigation. I want to try and practice this for us so we can see it. So let me open my code before. So this is um, this is where we are injecting the components over here. Over here. Now, what we need to do is lazy load this component before we render it. So what we just have to do is to do this. Const lazy load recap. So what we need to do is that lazy. So we pass the components we want into it. We want to pass the cap component into it. I don't know if you guys can see my screen very well. So when we render this recap, instead of passing the recap to you directly, we can now implement a suspense. Suspense means that you want to show when the app is loading. So you pass this thing, this component, all the component we want to have will be wrapped inside this suspense. Where do you want this suspense to fall back? Like, what should happen when the website is loading and the component cannot load at that time? You want it to display loading. So we put it inside suspense, and instead of using this recap, we use this component. Let's load the components. Now, if I run this website, this React app, can we? I don't know if we can see the screen very well. You guys should pay attention to what we have on this upper part where I put my cursor. Can we see that? Before the app load, before it bring the components up, that is what we first execute. So now, if at any time the web page and the components cannot load, it will only be showing this loading. But the moment this component is load, everything that requires the component to load will be load instantly. It will not keep on loading it anymore. It will not bring, like, it will not render it anymore. The one it render once is what it will display to us. Can we all understand? Do we all get that? Hello, can we move on? Can we proceed? All right. So now, if we are now using a class component, instead of us using hooks the other time, this is what we will be using. Should component update. Do we understand that class component and functional component is very different? And the way we manage states and props in these two component type is different. We have access to inbuilt React functionalities like use effects, use states, and a lot more whenever we are using functional components. Let us have it in back of our mind. Anytime you come across use function, that is a functional component. But now, whenever we're working with a class component, that is where you are going to be seeing components should mount, components will mount, component this, component that as a function. All right. So now, component update is still another one of the function inside the class component that give us the ability to play around with our components. What it does, it controls whether a component should render or not based on changes to props or states. This is just an English. Let me break it down to us. What this will do for us is that it will compare the properties we have. Let us assume we define a properties called administrator name, like the name we want it to display in our profile. This component should only mount, like it's only re-render when the name that we set into that state. Let us we define Murtado Sodiq as the name when the component first render, and we have it in cache, we store it. Now it will now compare the component and the data saved in that variable, which is the value. If it did not match what is being sent, that is when the component will render. But the moment that value is equals to the same value, the props, this props dot value and the next props dot value, the value that is being sent and the value that is half, because this props dot value is the value that is holding in that component, that is in that component, current component. Should components update, this will only execute when the two value did not match. Maybe the name of the profile, I've updated my profile name, I've changed it from Murtado Sodiq to Murtado Sodiq Adewale. Three name is a change. That's when the component will be render. All right. So this is very, very useful for us, and we should actually play around with all these things. I believe now that we might just be looking at all these things, but the moment we take a step that, okay, what does all these things mean? I can tell you for a fact, all these things, it is when you sit down, go through the documentation, read ups to understand all these things. All these things is not very hard. It's just what you have and how you understand it. It's not every time that you are working that you have to use all these things. The it's like the end goal when you are building a system. You already build a fully working functional application. All right. Before we push these things to application, what are the things that we need to manage? You don't know how much user will be using your application. You are designing a system that maybe you are designing a system for your school, or you are designing a student application for an e-commerce system. You don't know the amount of user that will be using it. To save you the stress of maybe they are calling you, oh, what you build for us is breaking, no, it's not loading, no. These are the things, all these simple things. It's not big. All these simple things is what you have to do. The component base, your navigation parts, your value, your hooks, your states, you pay attention to all those things. So um let's move on to the next slide. All right. So now I've explained the React memo and I've explained what it does. It prevents render when props haven't changed. Like I explained the other time, it's only the render when the props change, the value in the props when it's changed. So all right, so the next slide, the lazy loading. So now this part, um, I believe we are going to go on a break now. We should have a short break now. It's our time for a short break. So we should be back soon. Yeah. Hello. Hello. We're back. Can you guys hear me? Um. Hello. Can you guys hear me? All right. So, um, this is where we stopped the other time, and I believe I explained what and how lazy loading works on the components layer, components parts of the React application. Now, part of the optimization techniques we have to put in place is optimizing image itself. A very good example I cited the other time, a system or a web application that has a lot of images is like the e-commerce application. I believe we all use Jumia, we all use all Big's e-commerce. This system consists of large images and is not only good to optimize the component and everything itself without optimizing the image, because the image is also making use of the memory. The the image is being fetched from a storage location that is saved. Let's assume the image is stored in SW3 buckets and S3 buckets of Amazon or Cloudinary. So the moment the API call the image, it might also take time to load it. And every time you scroll up, you scroll down the image, you are making API requests to get the image every time. It's not scalable. What you can do for the image is to preview an image like a dummy image. So when the image actually load, you will now replace it with the actual image. I don't know if you guys get what I explain by that. What I mean by that. The initial image you want to load is being saved inside another server, is on another server. And we have to load that image the moment the web page is loaded. Now, before we wait for that image to load, let us give them a dummy image, like the way we did on the component base the other time that we present loading to us. But this time, you can just present an image that is being saved on the server. Let us assume like a loading kind of image or a dummy emoji image. So when that image comes in, it will replace this actual image will be replaced. All right. So now, what is the next step after that? Or what is now the use case for that? The use case is that when you scroll up or scroll down, let us when you scroll up, we have something we call the viewport in the React or in the web engine, web design system. The viewport is like the viewport is the height of your web when your screen size, the height of the screen size you're using. So whenever the image is no longer within the viewport, the image will not be rendered. That is it will not render that image until it's within the feasibility of the user that is using the web page. I don't know if that's if you understand what that means. When the image is no longer within the viewport, the image will not load until the image is within the viewport. That is when the image will load. And before the image will also load, we should present a dummy image for them so that when the image loads, you use the tag lazy and loading equals to lazy and present something for them. All right. So let's go over this definition and the benefits. So what we mean by the lazy loading, delay image and loading of off-screen image. Okay, this is the perfect word for it. Off-screen. That is the data or the image that is no longer in the visibility of the screen, off screen, but in the CSS or the JavaScript or React front end design or the engine. The term used for that is called viewport. Viewport. Let me show us what it means. We can all write that down. Viewports. So viewports is the user's visibility area of a web page. Can we all see that? So it varies with the devices, and maybe you are on a mobile phone or computer screen. But the cocoa is that you understand that this lazy loading only works when the image is within the screen of the user. Something you can see like this. That's when it's being implemented. Or components until they come into view. Now, the benefits. It reduces the initial load time by defining the image and defining the loading of a content that is not immediately needed. Simple as that. The image or the component that is not being needed at that time. Give them something. Give them this dummy image. Then when the image is actually needed or it has been successfully loaded, present it to the user. Now, how do you define it without actually using too much terminologies for that? All you need to do is just define the loading tag in the image as lazy on the attribute of image, img. I believe you're all familiar with img tag. All right. So the solution for components: use React lazy and components to load components only when it is required. That is for components. But for image, you use loading equals to lazy. Simple as that. It's not something big. All these things are just simple tag, and we only use it based on how deep our understanding is on this thing. All right. So now we now have something we call reducing JavaScript bundle size. I believe I show us the bundles itself. Like we bundle the build file of the React. Okay, let me explain something to us on that. I can tell us that when we run npm run dev, it will run the actual system for us, right? The actual React application. But what about the build file that is supposed to run in production? Can we also run it locally? The answer is yes. We can also run it locally. Let me run this for us. npm run dev. I want to show us something. We should all pay attention to this. npm start. We should pay attention to this. I want to show us something. All right. Can we see my screen? I run the application like normal way we run React. npm start. Now, we have something we call developer tools. Whenever we are working, we're on the browser. For example, you're on the Google Chrome. You can access developer group inside the extension. I don't know if you guys are familiar with this. You can go to the web store and install the developer tools that you want to use. You can search for developer tools over here. If you search for React, it will suggest tons of React developer tools for us that we can use to keep track of our application, the usefulness of it. What else? What are the things we need it for? But I will give us a glimpse of an iceberg on what we can use this for. So now, this application, this web page is running on React. So now, the moment you come to this, your developer tools, React developer tools, you click on it, it will tell us that this web page, it will tell us the environment is running on. This web page is running, and this web page is using development build of React. That is, we are running in development mode. All the 356 MB file that the folder is using is what is running right now. It's not running the optimized file of the application, that is the production environment. So now, if we click on it, where is it? It's telling us, note that development build is not suitable for production. Now, what we are building here will be faster because it's on development. When you push this production, this development to production, or this folder, it will be very, very slow. But where I'm going is that the moment you see this is on development. Now let us run the production environment for us. If I do this, you stop the execution, npm run build one more time. We run this build to generate the new build, npm run build. I want to run the build for us, like normal way. All right. So npx serve -s the build. So now this is production environment. I want to run it for us. All right. So the production environment, this is it. We are running this application the way it's going to run and execute in production environment. So if I come back here and refresh this app, and I'll now check the React developer tools one more time, can we see what tell us? This page is using the production build of the React. Can we all see that? Open the developer tools, and components and profile tabs will appear to the right. Now, why are we using React developer tools? I believe that question would pop up in your mind the moment I show us what the React developer tools is. Now, what are the things we use the React developer tools to do? We use React developer tools to manage how the React or the application is being executed, to keep tracks of the data that is being passed around in the application. The state management. We write code to manage states. We don't actually see the value inside that state. I want to show something over here. This next props.value is actually a value, like a data. It can be a name or maybe an age, a number. This dot props is actually a value, but we cannot see it. That is where React developer tools comes in. React developer tools will show us all the data inside every component, every data that we define. Everything will be shown here. When we set, I don't mean we set it up. Everything will be displayed here. Everything, all the Redux, the way you are moving around, you are passing data from one Redux to another Redux. How the component is being rendered. It will list everything, the high order of components, how the component is being rendered from one component to another. How is it pass data to? Can we all see this? This component, the data we pass to it, mic as a props. You can all see everything. So now when we start working with, we start building components, we start building our actual application, we start using React state management like Redux, or we are using React query, we are going to be seeing everything over here. So that's the full function and an overview of what React Developer Tools does. All right, so let's go back to what I'm explaining. Okay, so we said another method is using tree shaking, in the sense that what it does, it removes dead and unused code from the final JavaScript bundle. Unused code, what does that mean? The code that we comment out. Any code that we comment out is not being executed. Let me show us. Inside this our React application, all this code is not executed, is not used. All this code, they are being commented out and is not used. And if we understand that how all these things actually work, this line of code, it takes up it's being saved inside a memory. There is a space allocated to it to hold this specific line, this line of code, this line that I highlight is being saved in the memory, but it's not being used. So why are we keeping it there? We should delete it when we are not using it. But imagine you are working with thousands of files. You cannot comment out you cannot be clearing the comments one by one. But some comments are useful because some comments show us how the code is being executed. Okay, for example, now this line of code, what am I doing here? You are looping through a specific data.map. You are looping through it and you're extracting all this name out of it. You are passing it into the props, the component of user. So now, any comment that we put here is being useful for the developer to use, but it doesn't mean that the comment is not useful. But we now have what we call tree shaking to remove that code, because when we bundle it, we no longer need that comment in production. We only need that comment in development. I don't can we all get that? Let me recap. Code that is not being used with comments. Some comments there are comments in codes that explain what the code is doing for us. That is that when next a developer wants to work on that code, all he needs to do is just read that comment. That comment is useful. But there are some comments that you comment a code that is not being useful. Both the two comments, we only need them in development. We don't need them in production. But to remove that comment when we are building, that's where this comes in. Tree shaking. Now, what does it do? Ensure that you are using exec import and export syntax, which allow for the tree shaking to perfectly work. Okay. Now, what do we have next? We have bundle analyzer tools. This is one of the techniques, but I'm actually not familiar with these techniques, but it's something we should note if we are being asked. It might not be the something things you use or you practice every time, but so far you understand how one method works, you also understand how the next method works. So it said use tools like Webpack Bundle Analyzer to visualize the size and the various chunks in your bundle. So why it helps is that it identifies large libraries or unnecessary code that can be optimized or removed. Can we understand that these two things is performing the same operation? Okay, let's move on to to the next part. So that's where we comes in into React developer tools, what we known as profiling and performance monitoring. All right, I think I missed this the other time. It shows us the performance. Like I said, it shows how the component is being rendered in the React developer tools. It's going to show us the tree, the arrangement of how the component works. Um, let me show us one thing now. Let me. I'm not allowed to show the application, but I'm going to stop sharing my screen and show the screenshots. Um, you guys can give me a minute. Okay. Um, Let me share my screen and show something. Can you guys see my screen? Um, I think it's network. Let us give it a minute to come up. It should be up any minutes from now. Hello, is my screen live? All right, can you guys see my screen now? All right, the screen is live. So when I tried to look up some things I can show us on the React tools, the React developer tools. So this is what I come up with. We can all see, we can all just Google search and take a look at what we have. Basically showing us how, can we all see this now? A perfect example is what we have here. Let me open this. Okay. It's showing us the component arrangements on the web page, on the tools. Can we all see the how we render that? The app, the header, a text to do text inputs, and another component called main section. So this main section component holds two components, a to-do list component and a footer component. So that's basically how the components will be listed over here. The way it's listed over here, because you have just one component. Then it will also show us what data is being held inside the state management. I want to find a perfect example. All right, and React developer tools, Redux. Let me search that. Exactly. This is what I'm looking for. Perfect. This is it. Can we see this? Um, can we see something like this? So this is how the developer tools looks like. It will show us, where is that picture? All right. How we are, how the action is being dispatched, how the state is being managed. Can we see? Oh my God. But I'm very confident that when next we start doing a hair, can we see this? This is what I'm looking for. The action that is being dispatched. Maybe you dispatch a login action, you dispatch a get profile action, you dispatch a logout action. When you dispatch a logout action, you want to clear your states. When you dispatch a login action, you want to save your profile into states. So these are the things you are just writing the code, but you will be seeing all those things in real time inside the React developer tools. The action that you execute, how the data is being saved in the state. Is it saved as an object or as an array? The data that comes from the API you call. So those are the things React developer tools show for us. Now, I've explained how you can check it. You can check it out. Go to your extension in the Google Chrome or any app you are using, any web browser you are using. Search for React extension in the Chrome Web Store and you install it. Then you get access to all this data. So now when we start working on, maybe in our next class, I don't know if we've reached to we've moved on to state management. That was when we are going to be executing all these things I'm showing us. So all right, let us move on to the last slide, which is the brief explanation and recap. The optimization of React's performance involve reducing and render lazy loading, the memoization and efficient state management, like I explained the other time. The state management, how we manage our states, how we save data into the states. Then the techniques like code splitting, virtualization, and profiling can significantly improve our performance. When you have visual access to your code how it's being behaved underneath. You can know what to optimize, what to reduce, what to re-architect. Okay, when you check your state from the profiling, you see how the component is being rendered. Oh, this component is not supposed to render when this action is triggered. Oh, this data is not supposed to save like this. Maybe you are meant to save an object into the state. You are seeing a string. You will have to like, oh, let me change it. Oh, when you try to when you dispatch an action, maybe you dispatch a login action, you need to clear the token from the state. You need to clear the profile. And the moment you fire login, you dispatch the login, you fire logout, you dispatch the logout action in your state, the data is still there. Oh, this is happening. This is what you need to do. Rewrite your code or fix the bug. Why is this component not loading fast? Why is this component not rendering? Oh, this component is rendering because this action is still true in the state. So those are the things that you work with and makes development very easy for us, and also have access to optimize our code and perform very well. So that will be the end of our class for today. And we should have one or two questions since the beginning of the class. And I would like to answer one question that is sent to me when we were on a break the other time. So they ask about which part of the component is to be focused on, React class components or functional components. So all I will say is that we should have an understanding of the two class, how it works, but the class component is the most widely used, and the functional component is the most widely used because of the hooks and how it's very, very easy to use. So that's what most developers will advise us to use. But me as a person, I will tell us that just have an understanding of how it works, because you can find yourself in an environment where you're contributing to an open source code and the pattern being used is a class component. So, and you're not familiar with it. But now that we are getting started, let us read it, understand how it works, and stick to the functional components. So thank you. Any other question? Ah, have you guys there? Any question? Do you guys have any question? All right. I will provide access to the slide. I will drop the link for us to access it. Okay, so in the absence of no question, um, I really wish us a very good night, and there's room for any question. Anytime the question pops up in our mind, we can always drop the question in the group, or you guys can personally reach out to me or any of the facilitator that you guys are comfortable with. So Thank you very much, and good night, good morning, good afternoon from everywhere, anywhere we join from. Yeah, bye.